In this short video we are to show that the sine and cosine functions of any angle, expressed as the sum of two angles, can be written in alternate forms, as expressed by these identities. We begin with a right triangle with an angle, x, and our definitions of the sine and cosine functions for an angle. Setting the length of the hypotenuse to 1 allows us to easily express the length of the other lines. The length of the side opposite x is expressed as the value of sine of x, and that of the side adjacent to x is expressed as the value of cosine of x. Now, we construct another right triangle, with angle y, atop the first. The side adjacent to y then has a length of 1. As cosine of y is given by 1 over the new hypotenuse, the length of this hypotenuse is 1 over cosine of y. Next, since sine of y is the length of the side opposite over 1 over cosine of y, which is the same as saying the side opposite multiplied by cosine of y, the side opposite y has length sine of y over cosine of y. Tracing out a right triangle with angle x plus y, and hypotenuse of length 1 over cosine of y, we can see our task clearly. We must solve for the length of the sides a, opposite, and b, adjacent to the angle x plus y to attain the respective identities. The length of a is sine of x plus some length we will call c, while the length of b is cosine of x minus some length we will call d. Now, by the lines c, d, and that of length sine of y over cosine of y, a new right triangle is formed. Let's call its non-right angles w and v. Since d and b are parallel, d, together with the hypotenuse from our first triangle, forms an angle equal to x. The size or magnitude of a right angle is pi over 2 radians, so v is equal to pi over 2 radians minus x. But the sum of the angles of a triangle is equal to 2 right angles or pi radians, also equal to w plus pi over 2, plus pi over 2, minus x, we can see that w minus x is 0, or that w is equal to x. Then, sine of x is also equal to d, over sine of y, over cosine of y, or, alternatively, d is equal to sine of x, multiplied by sine of y, over cosine of y, and, c is equal to cosine of x, multiplied by sine of y, over cosine of y. Now, we can substitute the newly found lengths of c and d into our formulas for the lengths of a and b, respectively, to complete the proof of the sum of angles identities for the sine and cosine functions.